All right, this video is about the third type of conic section. Basically, if you took the equation that we have up top here, it might look a lot like an ellipse. Notice we've got our x squared and our y squared will be centered at 3, -3. If you know the formula there, x minus h, y minus k. Again, we've even got a squared and b squared on the bottom. But notice in the middle, this isn't an addition sign. So what kind of name would we give this graph? Well, if we graphed it out, you'll notice two different branches going on here, and this is what we call a hyperbola. A hyperbola is sort of like an ellipse. It's got the kind of the basic same setup, kind of, only now instead of curving inward, right, to where our two curves would sort of connect and make that oval shape, we're sort of curving away from one another. Hyperbolas have two what we call branches. Two branches. They also have two axes of symmetry, much like an ellipse. An ellipse, we called them the major and the minor. For a hyperbola, we're going to call it the transverse axis. That's the axis that will go through the two vertices, kind of cutting your two branches in half. And there's also what's called the conjugate axis. It's perpendicular to the transverse axis. Again, if we're at x equals 3, that's exactly where this one would have been, because it's halfway between those two vertices. And again, the transverse axis is exactly y equals k, essentially. Y plus 3 meant that we're going to be at -3. Made sense for why that would go through those two vertices. Now, for the details of how to make a hyperbola, it's going to be, again, very similar to an ellipse. If we have a squared and b squared, now you'll notice in both of these equations, a squared is always in front. What we've actually switched are the x and the y. For an ellipse, again, we always put the x squared first, and then it was just a was always bigger than b. That's not the case for hyperbola. A is always in the positive fraction, subtracting, again, the other fraction, and b squared will always be in sort of that second part of the difference there. Again, to have a horizontal transverse axis, that means that our parabola, or our two, branches, they're not parabolas, branches of our hyperbola, the two branches will travel in the x direction, so x squared minus y squared. X squared will be first. Notice A travels again from center to vertex, B travels the other direction, and C is still center to focus. For our vertical transverse axis, well, that just flips around. Y squared is subtracting x squared, y squared minus x squared. A squared is still beneath the y squared. So A is still traveling, again, from center to vertex. C is center to focus. And again, B is the other direction along that conjugate axis. But again, A and B are going to define sort of this box shape for us. It's going to really help us graph this hyperbola. Because again, the ellipse would have sort of fit inside that box. But since we're going outside, we want something to be able to guide us. And the thing that's going to guide us are the asymptotes. So taking a good look at our graph, you'll notice I removed that orange box. The asymptotes run directly through the corners of the box. So again, it goes from this green corner to this green corner. So B units right, A units up, which also means that the slope of that line, that rising line, is A over B, or the old rise over run. So you'll notice down here K plus or minus, because again, it depends on where the center is. So we're shifted H and K. But then we're going to go B units right and A units up. And we're going to form that line, again, through the corners of that green box. If the line going the other direction, the only thing that changes is that would be the negative A over B, or basically the opposite slope, if you will. But again, still going through the center, so it'll still run through H and K. And again, it'll just guide itself with a negative AB slope. The same thing actually works for the horizontal transverse axis. You'll notice this time, again, since we're going left and right, x squared minus y squared, that A goes to the right, which just means that the slope of our, again, lines, this time isn't going to be A over B, it's going to be B over A. B is the rise, A is the run, and again, our lines will guide those hyperbola branches. So you'll notice I go from the vertex and sort of curve up and away, but we're going to guide ourselves right along those two asymptotes. Right? We're going to follow those. So whereas a parabola might curve a little bit extra, it would sort of curve away from the asymptote, our lines are just going to go closer and closer and closer, and it'll look very much like a very large X shape when we're done. It'll look less like a U and much more like a big X if we zoomed out a lot. Now, let's take a look at a good example of one of these situations. So you'll notice I'm in sort of general form. We've got y squared minus x squared, which is a good hint that this is likely a hyperbola, not to mention the directions say so. So if we want to find all of the various parts, the first thing we're going to need to do is get back into sort of our standard form, or a more helpful form. So I'm going to divide all sides by 324. 36 over 324 and 9 over 324, they just happen to reduce nicely. It's kind of a nice example. And in that case, now that we have y squared minus x squared, we're equal to 1. Again, we've got our 9 and our 36 on the bottom. That means that a, always the front term, is going to be 3. And again, because b squared would have been 36, b is 6. Now, one unique relationship for hyperbola, much like it was for an ellipse, a and b and c all have a relationship. Now, for an ellipse, it was sort of, kind of weird. It was a squared minus b squared equals c squared. For the hyperbola, it's nice. It's actually just the old Pythagorean theorem. A squared plus b squared equals c squared. So for us, 9 plus 36 would equal c squared. And the square root of 45, or about 6.708, is going to help us find our foci. In that case, we can again also say, well, hey, if we're going, notice y squared minus x squared, we're traveling vertically, right? It's going to be a vertical axis of symmetry. That means that our vertices would have been up and down 3 units. Our foci, again, are going to be up and down 6.7 units. If we really wanted to, we could find the eccentricity as well. It's not going to help us graph very much, but always a good thing to find. Again, still c over a. And you'll notice for a hyperbola, your eccentricity will always be greater than 1. For an ellipse, it was always between 0 and 1. For a hyperbola, it'll always be greater than 1. So in that case, let's go ahead and draw the box onto our graph. Now you'll notice that I've chosen to sort of count by 2s. Again, we're going to call this 10 out here. And we're going to call this 10 up here as well. Purely because, again, to draw hyperbola, we're going to go outside the box. So we don't want the box to be the entire size of the graph, or we'll have nowhere to draw. But you'll notice, again, I went up and down 3 units to get to my vertices. I also went right and left 6 units. Right? Those blue points, or those b values, are 6 units left and right. So now I can draw in the asymptotes. Now you'll notice I haven't calculated the equation of the asymptotes, but you don't necessarily have to in order to actually draw the asymptotes. So again, we're going up 1.5, right 3 tick marks here. So I'm going to go up another 1.5, right 3 tick marks, sort of ballpark out here where I'm going, so that I can draw through the center, through the corners of the box, the asymptote in that direction. And then I'm also going to do the same thing, again, through the corner of the box, through the center of the graph, and through the other corner of the box. We're drawing those asymptotes in this direction. So that now all we have to do is place our foci. So again, they're going to be 6.7 units. So 4 makes 6.7 units. So right up in this area. And again, same thing, 4 is 6.7 down in this area. And now we just draw in our hyperbola. Again, follow from point. Again, we're going up and down around the focus, right, beneath the focus. We're going to run through the vertex along the asymptote. And again, along the asymptote to the vertex. Hopefully your line's smoother than mine. See if I can do better on the bottom here. Follow the asymptote through the vertex. Follow the asymptote. And as smooth as you can, drawing in that hyperbola. Now, if we did want the equation of the asymptotes, again, just remember that a went up and down, so it's rise a over b, the run. So basically, again, we don't have an h and a k. We were centered at 0, 0. Notice again, y squared and x squared, nothing subtracted or added. But again, we had a slope of 1/2, or basically 3 over 6, a over b, right? Slope of 1/2, both positive and negative for those asymptotes. Hopefully that helps you graph a hyperbola. Let's take a good look at just a couple of unique facts about hyperbolas. Oops, and I forgot. Here's another example, actually. Let's do this one first. Now, this one is in a larger general form. So first thing we need to do is complete the square. So I'm going to group my x squareds and my x's, and I'm going to factor out that -4 that was in front of x squared. The same thing, I'm going to group my y squared with y, and there's nothing to factor out this time, so notice nothing in front. I'm going to leave a little space though, so I can make those perfect squares, and I'm going to take that 95 and I'm going to throw it to the other side. So that now I could say, well, half of negative 10 and half of 6 would have been negative 5 and 3, which means negative 5 squared is 25, which times negative 4, remember if I add 25 inside, I really subtracted 100. I'm going to balance by subtracting 100 on the other side. Same thing goes, half of 6 was 3. Up top here, that would have meant a 9, right? 3 squared would have been 9. Y squared plus 6y plus 9 factors correctly. But again, if I add 9 times 1, nothing in front, I need to add 9 on the other side. Adding up that other side, basically this would have been a negative 5 plus 9 is 4. I'm going to divide all parts by 4 and come out with my equation. So at this point, think about the a value, the b value, the c value, so you can find all the things we found on the previous screen. Fill in the details, and let's see what your hyperbola looks like. All right, let's talk through just a couple of the details. Again, a is in front, so we've got a 2 for a. A happens to be greater than b this time, so you'll notice a very narrow hyperbola, because again, we went up 2 units from the center, and we went out only 1 unit left and right for b value. So we're traveling north and south here, we're traveling up and down. Our asymptotes get very kind of vertical, though. They're very, very kind of squished top and bottom. So again, we get a much narrower hyperbola than we did last time. Again, you'll notice again the center was at 5, negative 3, so be careful. We want to travel up and down. We want our y value to be what we're adding a onto and subtracting it away from. So negative 3 plus 2 and negative 3 minus 2. And then we're also going to take that same idea, take that center, we're going to add or subtract the c value to get the foci, which notice are very close to the vertices because, again, it's a very narrow parabola. Our eccentricity was only 1.118. I hope that helps you graphing, again, hyperbolas. Let's look at a couple of fun facts. Number one, if you want to classify a general form equation, more than actually doing all the completing the square, there is a faster way to do it. And that way is to take advantage of the values of a times c. So if you have a general form equation like this, notice we're missing the b value because we're not going to deal with any general form that has x times y in it right now. That's a much trickier thing. Maybe in a different video you can see that. But if you just take a times c, the rest of these don't really matter. If a times c is 0, it's going to be a parabola. So you'll notice over here at the left, this equation didn't have a y squared value in it, which means that a is 4, c would have been 0, and 4 times 0 is 0. That's going to be a parabola. Notice if we do the same for the other equations, 2 times 4 up top would have been 8. Well, it kind of makes sense. X squared plus y squared, we should get an ellipse. 12 times negative 1, right? Well, hey, x squared minus y squared, we should have a hyperbola. And down at the bottom, 2 times 2 would have been 4, which is greater than 0, so it should be an ellipse. But now wait a minute, an ellipse that has the same value both times, if a equals c, therefore we're going to have a circle. It'll actually be a perfect circle, your a and b values in your standard form equation, right? Your major and minor axes would have been the same length. So again, kind of a unique way to kind of identify which type of a conic section are you looking at. One other fun fact about hyperbolas would be this fact here. The hyperbola is actually defined by the fact that any point that's distance from the focus and distance from the other focus, the difference between those distances is actually how a hyperbola is defined. If that difference between the distances is constant, and if the difference of the distances is constant, it's also actually equal to 2a. If you look into that transverse axis, it's kind of a unique relationship for hyperbolas. Kind of a fun fact there as well. Last thing for you is just how do we go backwards? So think about the details on the screen here. I'm going to write in the answer, and let's see if we can't come up with the equation for this hyperbola. All right, I'm taking a very quick look at this. Again, halfway between the two vertices, we'd have our center. So our center is 2, 4. So notice we've got our 4 and our 2 in our equation. I knew that it was traveling vertically because I plotted those two vertices, or at least sketched them out, which means that y squared minus x squared. And I also know that, again, that vertex to center, 3 units is a, so that's a 9 for a squared. And I used the foci to get c. C squared and a squared, finding us b squared at 16, and we've got our equation. I hope that helps. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.